Welcome everyone. In this video, we will discuss a topic that can sometimes be a little confusing. Specifically, we want to discuss why electric current, which we denote by I, is not a vector. And of course, if you did a little bit physics, if you have taken a couple of classes in physics, and especially if you did circuits, you should know that the electric current is not a vector. It is not a vector. And as I said, this is common knowledge probably for most of you. But when we think about it, it's kind of interesting. Because, come on, what is a vector? With the most basic definition that we use in physics, it's a quantity that has a magnitude and a direction, right? I mean, if it only had a magnitude, it would be a scalar. For example, temperature is a scalar, right? Because there is no direction for the temperature. You might say that today the weather is 20 degrees Celsius, but you can't say it is 20 degrees Celsius to the right? You can't say that. It does not have a direction. On the other hand, some quantities, for example, displacement, is a vector. Because if you say that, let's say, I moved 10 meters, that doesn't give enough information. I mean, from that we could, if you start here, we could only guess a like a radius of 10 meters, right? If you say I displaced 10 meters, this is the guess that we could make, and you could be at any point on the circle. But if you give a direction, let's say that you say I displaced 10 meters to the right, well then we know you're here, okay? So vectors are quite useful. But think of the current now. Whenever we say current, we say, let's say that we have a circuit, okay? It's a basic circuit. We have a resistor and a battery here. And whenever we draw this, we will say, let's say, we have a current and it flows in this direction, right? We say that there is a current flowing from point A to B. Maybe this is A, this is B. We would say this all the time while analyzing circuits. We would say current is flowing in this direction and it has this magnitude. So how is it that current is not a vector? Well, let me explain it to you. It is not a vector. We do not define it to be a vector. Because if it was a vector, there would be weird things happening. And let me show one example. Let's say that we have hold on, let me draw a resistor, okay? We have this kind of a setup, okay? And there is another battery here. We don't even care about the resistors. Maybe this has R1 resistance and this has R2 resistance. And I want to calculate the current flowing through this one, okay? Let's say that I1 flows through R1 and I2 flows through R2. Of course, we know that it will travel like this. So this is I1, this is I2, right? Now, the interesting part is here. Look at this. Look at this box that I just drew. If we were to treat current as a vector, how would we add them? I want to add I1 and I2. If it is a vector, how do I add them? Well, they are in opposite directions, right? They are in opposite directions, so I would subtract their magnitudes, and which one of them is hold on, I couldn't say it. And the one with the greater magnitude will win. So let's say if I2 is greater, their sum will be upwards. And that makes absolutely no sense for this problem. Because we know that when we add I1 and I2, we will get I, which is to the right. And notice that even though they are different in magnitude, they are opposite in magnitude, even though they are opposite in direction, as we can see here, we still add them. and the result is not in the vertical direction, it's actually in the horizontal direction, okay? And you can intuitively know this is right, because if you think of the current, it is basically a displacement of charges. And if you have an amount of charge displacing through here and another amount of charge displacing through here, they will flow through this wire, so the total displaced charge will be the sum of the two displaced charges, right? So as I said, we can intuitively see that this is right. And so that basically tells you why current cannot be a vector. We don't define it to be a vector, because if it was a vector, we would need to do vector addition with it, and it would make absolutely no sense, even in this kind of a very simple question. Anyways, I hope this video kind of convinces you that current should not be a vector, it is a scalar, for a reason, because when we do vector addition with it, it gives results that don't make sense. I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. For that, please make sure to subscribe. And that's it. Until then, take care.